Hey now, today we're going to be talking about 10.1, apply the counting principle and permutations. Something new, something different. I think, however, that you will do well. I will tell you that if you don't have your graphing calculator out right now, please press pause and go get it because there are a couple, two, three things that you're definitely 100% going to want to see that on. Promise you that. If you don't have a graphing calculator, I'm going to wish you luck with this. So, example 1. An object is attributed from each list. Make a tree diagram that shows the number of different objects that can be created. So as we go through the notes today, pretty much what I'm mostly going to do is I'm going to show you the different things that you're going to be able to see, like tree diagram, and then instead of giving you a definition, because in this section the definitions could be a little bit tricky, I'm just going to show you what it looks like and then you can see it from there. So we're going to use a tree diagram to figure out how many different combinations of outfits we can create if we have these types of tops and these particular choices for our bottoms. Should look a little bit familiar to you. So you're going to start with the tops, and we have a blazer, which I'm going to use BL. We can have a cardigan, so CA. We can have a hoodie. Oh, no. We can have a hoodie, or we can have a sweatshirt, or we can have a sweater. Okay. So for each of these different tops, you have some choices for your bottoms. You have three choices. You can have sweats, you can have a skirt, or you can have pants. That is what you can wear with your blazer. Now for your cardigan, you can also have the same three options. So I'm going to branch this out and go for sweats, skirt, or pants. And then again for the hoodie, you can have sweats, skirts, or pants. For this option, you have sweats, skirts, and pants again. And for your sweater, you have sweats, your skirt, and your pants. So the question was how many different combinations or how many different objects can be created. So you can wear your blouse with your skirt. That's one option. You can have your cardigan with your pants. That's another option. So how many total are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 objects or outfits can be created. Now, there are going to be times where I'm going to tell you to use a tree diagram. And if I tell you that, then that's what I want you to do. Use a tree diagram. Why did I tell you that? I told you that because now when you look at the bottom part of your page, you can't see it completely on here, but it says the fundamental counting principle. And that reads, if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. The same principle works for more than two ways. So if it was like not just tops and bottoms, maybe tops, bottoms, and types of shoes as well. Then what you would have is, for this example, 5 times 3, because you had 5 choices for your tops and 3 options for your bottoms, so you had 15 total. You will not always have to do a tree, but I did want you to want to show it to you so that you would be okay if you did have to do that. All right, onward. All right, so given the fundamental counting principle, we know that each event can occur in the given number of ways for part A, B, and C. What they would like for us to do is to find the number of ways all of the events can occur. So I have event A, there's 5 ways for that one, and I have event B, and there's 2 ways for that one. So what's the total going to be? Well, for event A, there are 5 ways, and for event B, there are 2 ways. So altogether, if I'm using the counting principle, I should just multiply 5 times 2 and know that there are 10 ways for this event to happen. 10 ways that the event can happen. All right, so for the next one, you have event A, you have event B, C, and D. So for event A, there are 3 ways, event B, 4 ways, event C 2 ways, and event D 5 ways. So when we multiply all of these different ways together, and you can check me on your calculator if you don't believe me, there should be 120 ways that those 4 different events can happen. Looks too easy? It's not. We're building here. So now for this one, you have event A, B, and C. So what are you going to do again? You're going to multiply the different ways that each one can happen. So 4 times 2 times 7. And then when you multiply those all together, hopefully you get 56 possible ways for those events to happen. Okay, meaning event A can come first, or event B can come first, or C can come first. You can just mix them up in 56 different ways. Okay, let's step it up just one more notch here. For the given configuration, determine how many different online passwords, is something we use all the time now, are possible if, for part A, digits and letters can be repeated, and part B, digits and letters cannot be repeated. So let's look at the first scenario. We're going to have 2 letters, so I'm going to give myself 2 slots. So that's going to be a letter, and then it's going to be followed by 1, 2, 3, 4 digits. So I'm going to have a digit, and a digit. Now letters, sometimes I take this for granted, but there are 26 letters in the alphabet. I know you know it, but it happens. How many digits are there? Well, 0 counts as a digit. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all together, if you count up all of these, there are 10 digits that are possible. Okay, so for letters, for part A of this problem, so this is part A of A, they said that digits and letters can be repeated. So let's look at how many choices you have for letters. How many choices are there for the first letter? Well, A through Z, so there are 26 choices here. And then for the second letter, since I can repeat them, I still have all those options, 26. Now for my digits, the first digit could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or one of those. So you have a total of 10 choices for that one. If it can be repeated, then I still have all of these choices for the next digit. And if I can repeat, I still have all of these choices and all of these choices. So what are we going to do? Well, we're going to use the fundamental counting principle and multiply all of these numbers. Go ahead and press pause if you'd like to, and check what the math would be on your calculator. And when you do, if you do, I believe you should have 6 million and some change. My thing is frozen, and that's why you don't see anything. 6, ooh, see how you did that? There it goes. 6,760,000. All that time you should have used your calculator. Okay, so for the next one, part B of this though, because they had 2 different scenarios. For part 1, we could not repeat anything. I'm sorry, we could. And then for part B of this, letters and numbers cannot be repeated. So you still have the same sequence. You can have 2 letters followed by 4 digits. So a digit, and a digit. So if they can be repeated, cannot be repeated, my first choice is 26 letters. Now, if they can't be repeated, then I don't have 26 letters to choose from anymore because I just chose one of them. Let's say I chose W for Williams. That's not an option anymore, but I still have 25 other letters to choose from. Now, for your first digit, you can pick any one of those 10 numbers. So I have 10 options. But then, let's say I picked 4. Now how many are left? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say I picked 6. Now how many options do you have? 8. And then for your last one, you have 7 options. Using your counting principle, you're going to multiply all of these numbers, and you should get 3,276,000. Those are your options for that. If you could please go ahead and press pause. I'm going to give you your setup though. So for part B, for part A of part B, I know it sounds confusing, you can have 3 digits, so digit, 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 followed by 3 letters. So for part 1, they can be repeated, and for part 2, they cannot. So go ahead and set that up, press pause, and I'll show you what I got in just a minute. Okay, so 3 digits followed by 3 letters. If they can be repeated, you should have 10 times 10 times 10 and 26 times 26 times 26. And this should be your answer when you multiply all those out. And then for your digits that can, in letters that cannot be repeated, you have 10, 9, 8, 26, 25, 24. And this would be your answer there. Check yours with mine, and then we'll continue. So the next thing we're going to do is evaluate. Now, this exclamation point is not me yelling at you, although I might want to sometimes, but it's not. It's actually another function, just how you would have addition and subtraction, multiplication and division, blah, blah, blah. This is another operation. It's just new for you. It's called factorial. The exclamation point is equal to, or means factorial. So just how a plus sign means addition, this exclamation point means factorial. Just instead of factor, it's factorial, except it's not really connected to factoring to that extent. Yeah, so my pen was frozen. Factorial. So what this means is that you're going to multiply 6 and then times 5 times 4 times 3 times 2, and you're going to stop at 1 every single time. Always stop at 1. Always, always, always. So you'll multiply 6 times 5 times 4 times 3 times 2 times 1, and you will get 720. That's factorial. Same things happens here. You're going to have, I would multiply these separately. So 4 factorial is 4 times 3 times 2 times 1. And 1 factorial is just 1, and then that's it. So 4 times 3 is 12, times 2 is 24, times 1 is just 24. Now you're going to get irritated with that after a while, because when you look at 14 factorial, that's kind of whack, because it's a lot to have to do. So what you're going to do now is take out your calculator, and then I'm going to give you the steps to type in here. First thing I would type in would be the number 14, because that's what you want. Then you're going to hit math. Do it with me. And then there's a button. It depends on what calculator you have. Some of yours says P. Just kidding, didn't see P. I just did it backwards. PRB. Some of yours will say PROB. Both of them mean probability. So you want to get to that using the arrows. You can hit the arrow, I think probably like 3 times to the right or just 1 time to the left, but it really depends on your model. But I think for everyone's, if you hit right 3 times, that'll get you to the PRB function. And then where's the exclamation point? I believe it's number 2. And then from there, no, it's not number 2, I'm just kidding. It's number 4. Number 4. And then hit enter. And that will give you a really big number. Now, again, depending on your settings, some of yours might say 8.717829112, then e to the 10th. That e to the 10th is scientific notation. It's telling you to move from your decimal point over 10 times, because this is positive, 10 times to the right. So you're going to go over, count 10 spaces, and that'll get you to your answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your final answer for that will be 87178. Don't forget, for these ones, you're going to put your commas in there as well to make sure you're okay. Okay, take a minute and try. Let's look at letter D. I have 8 factorial times 4 minus 2 factorial, all divided by 5 factorial. You can kind of put most of this, if not all of it, into your calculator, but let's do this separately first. 8 factorial, and then order of operations means that you should do your parentheses first. So 4 minus 2 is 2 factorial over 5 factorial. All of this you can put directly into your calculator. So type this in, but I would put this in parentheses, then put divided by 5 factorial, and once you do, you'll get 672. But if you did not have it and you only had a baby calculator, you can do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 for your 8 factorial times 1, and then your 2 factorial is 2 times 1. All over, well, what's 5 factorial? 5 times 4 times 3 times 2 and times 1. Cancel what you can cancel, And what's left is just 8 times 7 times 6